Good morning, everyone. It's Miss Trenham here for 7th grade math. I hope you had a great week last week. Hope you did something special for your mother over the weekend. Last week we talked about MAD, remember? Mean absolute deviation. And I told you that this week we were going to be talking about probability. So let's get started. Probability. Last week I gave you this to think about. This question right here to think about. A game at a school carnival has 3 different spinners. Which spinner is more likely to land on A? Which one do you think? I think I agree with you. Spinner 2 is more likely to land on A. In our first spinner, A, B, and C are equally distributed in the spinner. So each time you spin, you have a 1/3 chance, a 1 out of 3 chance of getting an A. On spinner 2, A is half of the spinner. So you have a more likely of a chance to spin an A on the spinner in spinner 2 because it takes up half of the spinner. In spinner 3, A only takes up 1/4 of the spinner. So you have a 1 in 4 chance of spinning an A. So yes, spinner 2 has more likely of a chance to land on A when you spin it. So let's look at what we're going to be studying today. We're going to be studying about probability. And we need to understand that probability of a chance event always lands between 0 and 1. 0 being absolutely cannot happen, and 1 being absolutely positively certain that that outcome will come. But before we can get started on our problems for today, we need to review a little bit of vocabulary. So let's go through some of the vocabulary that we will be talking about today. So our first vocabulary word is probability. That's what our whole lesson is on today. Probability is the likelihood of an event happening. The likelihood of spinning an A. That was what probability was. Experiment is a repeatable procedure involving chance that results in one or more possible outcomes. Now, you've all done experiments in science, so you know that you have a theory about what you're going to find at the end of your experiment, and then you do the experiment, and then you have outcomes. How many ever times you repeated that experiment, you may get the same result or you may get different results. That is possible outcomes. The next word is actually outcome. It's one of the possible results of an experiment. So just like I said, the more times you repeat an experiment, the more outcomes you get. An event is a set of one or more of those outcomes for that experiment. Certain is the probability that an event, when that specific event will definitely happen. Certain means it absolutely is positively going to happen. Now, a minute ago, when we spun the spinner, A was only 1/2. If the spinner would have been only A, the whole spinner would have been A, no other options, that would have been a certain, because no matter how you spin it, you were going to land on A. An impossible event is the probability of an event when that will definitely not happen. So if you take the spinner that we looked at a minute ago, and you added, if I ask you what would have been the probability of spinning D, that's impossible because the D wasn't even on the spinner. To calculate probability, you always use this fraction or this ratio. The number of desired events or outcome, the number of desired outcomes over the total number of all possible outcomes. So let's see what we mean by that. We have 2 different shapes. We have stars and we have circles. What if I put all of these shapes into a bag and shook them up? What is my probability of drawing a star out of that bag? Well, how many stars do we have? 3. And we have a total of 6 shapes. So my probability of pulling a star out of my bag is 3 out of 6, which is the same as 1/2 or 0.5 or 50%. So I have a 50% chance of pulling a star out of the bag, just like I have a 50% chance of pulling a circle, because they are equal. There's 3 stars and 3 circles. So let's look at this diagram talking about the words that our vocabulary words and our probability. On our number line, if you were to have 0, 0 is an impossible event. If I went back right here and asked you, what is the probability of pulling a square out of the bag? 0% chance, because there's not even any squares up there. So that is an impossible event. Okay? When we looked at the spinners a minute ago, and I showed you that 1/4 of the spinner had B on it, and I asked you, what would be the probability of spinning a B? Well, that would be 1/4, because it only covers 1/4 of the circle. That is an unlikely event, because the 3/4 of the circle is covered by another letter. When we picked our actual winner of spinner 2, A covered half of the circle. So that is an equal likely event. If 1/2 of the circle is A and 1/2 of the circle is B, you have a 1.5 chance or a 1.5 chance of spinning an A or a B. Just like right here, you have a 3 out of 6 chance of pulling a star or a 3 out of 6 chance of pulling a circle. When you get to this one, the 3/4, that is very likely. If on our spinner, A was 3/4 of the circle, we would have a 3 out of 4 chance of spinning an A. That is a likely event. And then remember when I told you an event that is certain, if our spinner only had A on it and no other letters, that is most definitely certain that we're going to spin an A. A is the only one on there. So it goes from 0 on our number line, which is an impossible event, to 1, which is an absolute certain event when we're doing probability. Now let's see if we can match the vocabulary with our actual numbers over here. So let's look at the first one, 1/4. So if you have a 1/4 chance, is that certain, equally likely, impossible, likely, or unlikely? Exactly. That is an unlikely event. 1/4 is an unlikely event. 1 out of 4 is unlikely. 0. 0 absolutely matches with impossible. If we don't have a square in our bag, how can we pull a square out? 0 is an impossible event. 5/10. 5/10 actually reduces to 1/2. So if you get 5/10, which vocabulary word does it match up with? It matches up with equally likely, because you have a 1/2 of a chance to pull a star out of our bag and a 1/2 of a chance to pull a circle out of our bag. 100%. That definitely matches up with certain. 100% is certain. If our bag only had circles in it, it is 100% chance that we're going to pull a circle out of that bag, because we don't have any other shapes. And our last one is 75/100. 75/100 reduces to 3/4. So we have a 3 in 4 chance of pulling a star out of our bag or spinning an A on the spinner. So 75/100 matches with likely. Exactly. Because 3 out of 4 is a lot better chance than 1 out of 4. Here's a question for you. What do you think? Thinking back over what we just talked about and on our number line, A meteorologist in Seattle says there is a 75% chance of rain today. A meteorologist in Tacoma says there is a 1/4 chance of rain today. In which city is more likely to get rain? Now, if you remember, back on our number line, more likely was the same thing as 3/4 or 75%. So if you chose Seattle as the answer, you are correct because Seattle has a 3 out of 4 chance of raining today. They have a higher risk of rain than Tacoma does. So let's see if you can answer these questions on probability. Number 1, let's look at the first one. What is the probability of landing on a number greater than 13? Well, here's our spinner. What is the probability of spinning and landing on a number greater than 13? 0. Do you see 13 on here? There's not a 13 on there. That is an absolute impossible outcome because we don't even have a 13 on our spinner. So number 1 is 0% chance. It is an impossible event. Look at number 2. What is the probability of spinning a 3? Well, let's look at our spinner. There's only one 3, and there's 8 total numbers. So that's a 1 out of 8 chance. Is that likely, unlikely, certain? It absolutely is unlikely. There's a lot of numbers on here besides a 3. So a 1 out of 8 chance is an unlikely event. So number 2 would be unlikely because the probability of spinning a 3 is not really a good odds for you. Number 3 says, what is the probability of spinning an even number? Well, let's look. We have 2, 4, 6, and 8. That's 4 even numbers out of a total of 8 numbers. So 4 out of 8, that's 1/2. That's pretty likely, right? I mean, we have a equally likely of spinning an even number as we do an odd number. So number 3, we have a 50-50 chance of spinning an even number or an odd number. So number 3 is equally likely. So look at number 4. What is the probability of spinning a number less than 9? Pretty certain because every number on here is less than 9. So our probability of number 4 is 100% that we're going to land on a number less than 9 because our spinner has 1 through 8 and all of those numbers are less than 9. There are 2 types of probability. There's theoretical probability and there's experimental probability. Theoretical probability is the number of favorable or desired outcomes over the total number of possible outcomes. Just a few minutes ago when I said, what is the probability of pulling a star out of the bag? Well, it was 3 out of 6, which was 50-50. So that would be a theoretical because we feel like that half of the time or every 3 out of 6 pulls would be a star out of our bag. That would be theoretical because in theory, we're going to pull a star half of the time out of our bag. An experimental probability is the number of times the event occurred over the number of trials. So in an experimental probability, we need to actually conduct an experiment. So going back to our bag of stars and circles, we in theory say that pulling a star out would be a 3 out of 6 chance. Well, would that last and would that be consistent if we did that 10 times? Would we always get a star 3 out of every 6 times we pulled a shape out of the bag? That is experimental. We need to experiment and we need to do some trials in order to see if that's correct. So let's look right here. The theoretical probability of this spinner. We have 4 colors, 4 numbers. So our probability of spinning a 3 would be 1 out of 4, correct? Because we only have 1 3, and we have a spinner that has 4 numbers. So if we look right over here, our number of favorable outcomes, which is 3, that's 1, out of a total 4. So the possibility of spinning a 1 is 1/4. The possibility of spinning a 2 is 1/4 because it's 1 out of 4. Same for 3 and same for 4. In theory, if we spin the spinner 10 times, we would have a 4 in 10 chance of getting a 3 every time. That is our theory, correct? Well, let's see if our theory holds up. Here's our spinner, and of course, right over here we see, theoretically, each color should be 25%. We should pull those 1/4 of the time. I went ahead and spun the spinner for you so we could get an idea, okay? After 1 spin, we landed on blue. After 2 spins, we had a blue and a cayenne. After 5 spins, we were 2 yellows and 1 for every other color. At 10 spins, we had spun red the most, then the next one was blue, and then cayenne, and then yellow. So if you can look, our experiment on 10 is red was the majority of the time. So if we use this same theory or this experiment and said, what would happen if we spun the spinner 100 times? We would, in theory, according to this, we would say red is going to be the majority because after 10 spins, red was the majority. Well, let's see. Let's conduct that experiment after 100 spins. So after 25 spins, our theory still stands. Red has been spun the most, has been our outcome the most. After 50 spins, we're still there. Red is still leading, and we have landed on red the majority of the time. After 75 spins, it gets a little different. Red's not leading anymore. Blue is now leading. And our numbers have gotten a little closer together, correct? After 100 spins, everything's kind of even. In the beginning, we said theoretically that we should land on every color 1 out of 4 times. Well, we conducted this experiment to see if that was actually the truth or if that was actually the result we would get. So after our experiment with 100 spins, it does look to be that our theory was correct because 27 times it landed on blue. That's 27% for our experiment. Our theory said 25. We are really close. On yellow, it landed 21 times. In theory, we said 25%. It actually was 21% in experiment. And the same goes for cayenne and red. So our experiment and our theory actually matched this time. Do you think that'll happen every single time? Maybe. The benefit we have on this one is that they're equal. Now you try. Jackie used an app to simulate a coin flip 400 times. It lands on heads 222 times. Based on her results, Jackie predicts that the expected number of times the coin will land on heads in 10,000 flips is 5,000 times. Do you think Jackie's expected results are correct? They look, if you think about it, yeah. That was about, half of the time that when she flipped the coin 400 times, 222 is a little over half. So she's pretty close, wouldn't you think? Well, let's actually look and see if her answer is correct and if her thinking was correct. No, her expected results are not correct, and let's see why. If we use equivalent ratios to find the probability, So we take 222 times 25 and 400 times 25 because we started with 400 flips and we needed to get to 10,000 flips. If we multiplied 400 times 25, that's 10,000 flips. If we do the same for the coin actually landing on heads, 222 times 25 would be 5,550. She was off by a pretty good bit, wasn't she? So based on Jackie's results, the coin should land on heads 5,550 times. So let's kind of think backwards now. I'm going to ask you another question. A family has 3 girls, and the family is thinking about having another baby, and they want to know what the likelihood of is it being a girl. So they decide to flip a coin and see, they flipped it 20 times to see if they could calculate their probability of having another little girl. So as they flipped, the heads was represented the girls and the boys represented the tails. The tails represented the boy. Out of their 20 flips, 8 times did it land on heads. So if the family has another child, what would be the prediction? So they've already conducted the experiment and they got 8 out of 20. So they have 8 out of 20. So their experimental probability is 8 out of 20. But we know in theory, there's only 2 choices, a boy or a girl. So you can't really base a coin flip because in theory, there's only one possible outcome if they want a girl. So let's think about this. What do you think? The theoretical probability is 1/2. Their experimental probability was 3/5. It says, what is the theoretical probability that the child will be a boy? Well, they flipped more coins this time. So their theory is 1/2, but their actual experiment came up different. So can we really predict in probability, in this case, that coin flips would result in saying if they would have a boy or a girl? Probably not. So let's review. There's 2 types of probability. Theoretical, which means what you think will happen, and then experiment, what actually did happen. Okay, listen guys. Thank you for listening today for probability. We are almost done. We have a couple of more days on our packets and our online study because all of that is due Thursday. Today's Tuesday, Thursday. Don't forget 2 days. All of your schoolwork is done. And then the next week, you need to make sure you take your iReady, your math, and your reading. And then guess what? 7th grade is finished. You will be on to 8th grade. So next week, we are going to look at what you are going to expect to see when you get to 8th grade. Okay? So we're going to be looking at exponents and writing equivalent expressions. And we're also going to be looking at repeating decimals and fractions and things like that. Okay, guys, I hope you have a great week. Don't forget, finish up your packets, finish up your online, and don't forget to take your iReady. See you next week on to 8th grade. Yay, Miss Trenham out.